So before we get into the actual binomial theorem, there's a couple things we need to go over that allow us to use the binomial theorem. The first thing is called a factorial. So this is a mathematical operation that you may not realize exists. Factorials, which is our first word for today, are mathematical operations that return the product of an integer and all of the integers below it. So the formula, which is confusing to read, says n exclamation point, which means n factorial, is equal to n times n minus 1 times n minus 2 times n minus 3, continued on until you're multiplying by 1. So for example, if we were evaluating 4 factorial, you would do 4 times 3 times 2 times 1. All of the numbers less than 4, you're multiplying together. So if you do 4 times 3 times 2 times 1 in your calculator, it would return to you 24. But of course, there is a shortcut for this in the calculator, and it's written there for you. Depending on the actual factorial itself, sometimes it's easy just to type the numbers, like 4, 3, 2, and 1 is not that many. But to actually type it in the calculator, you're going to press Math and then highlight the probability screen. So that's over to the left or over to the right. You can go either direction. PRB is for probability, and the fourth option is exclamation point. That's your factorial. So either by figuring out the numbers yourselves, like 6 times 5 times 4 times 3 times 2 times 1, or pressing 6 factorial in your calculator, we can evaluate these expressions. So 6 factorial is just by hand 6 times 5 times 4 times 3 times 2 times 1. But that's a lot of numbers to type in. So if we do 6 factorial in your calculator, you should get 720. Now 10 factorial, again, that's starting to have a lot of numbers in it. I don't particularly want to type 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's one for sure I would use the factorial key for. So we do 10 factorial in our calculator, and we get 3,628,800 as 10 factorial. Yeah, they get big really fast because we're multiplying all of the numbers less than it. But the reason we need factorials is because they're used in what's called a combination. All of these things are going to build up to our binomial theorem. A combination is a selection of numbers if r and n are integers with r bigger than 0 but less than n, so n is bigger than r. The symbol n choose r, which is how you say that out loud, is defined as n choose r is equal to n factorial over r factorial times n minus r factorial. It's a lot, but you're just plugging the same two numbers into this formula. This is going to be a big formula for you today, so if you wanted to like circle, highlight, star, underline, this is a good formula to do that with. So if I was doing 3 choose 1, using the formula, n is on top, r is on bottom, this would be 3 factorial divided by 1 factorial times 3 minus 1 factorial. We'll do a few of these by hand just because some of the numbers are pretty small, but when the numbers get bigger, we'll use the calculator for this. 3 factorial is 3 times 2 times 1. 1 factorial is 1. 3 minus 1 is 2. So this is 2 factorial, 2 times 1. The shortcut here is if you notice numbers are on top and bottom in this formula, what do? Cancel out. They cancel out. So we could cancel all these out. And what is this equal to? 3. 3 over 1 or just 3. So 3 choose 1 is equal to 3. Let's do 4 choose 2 by hand. 4 choose 2 would be 4 factorial over 2 factorial times 4 minus 2 factorial. You see how I'm filling in the formula? That clear? Well, 4 factorial by hand is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 4 minus 2, which is 2, factorial, is 2 times 1. Again, I can let some of these numbers cancel each other out, and I would have 12 divided by 2, which is 6. So 4 choose 2 is 6. At this point, these numbers would get really big to actually write out because I'd have to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we'll go from the formula and then put the formula in our calculator and press go. This 8 choose 7 would be 8 factorial over 7 factorial times 8 minus 7 factorial. But at this point, again, these numbers are a lot bigger, and I definitely didn't leave you enough space to write all of those numbers out, so we'll go to our calculator. I prefer to use the fancy fraction on this one just because then I can see that I've typed it in correctly. So alpha y equal enter, we have 8 factorial divided by 7 factorial, open parentheses, 8 minus 7 factorial. Give you a second to type that in. What do you get? 8. 8 is correct. Now, truly on letter D, we definitely don't want to have to do that one by hand because to write all of the numbers from 65 to 1 and then have to cancel some stuff out, that'd just be super messy. So we set this one up as 65 factorial over 15 factorial times 65 minus 15 factorial. Now, if you can't help yourself but actually simplify those numbers in your head first, that's fine. But if it's asking you to type in the formula the way the formula writes it, this is the way the formula writes it. So we turn to our calculator. We make a fancy fraction. We say 65 factorial divided by 15 factorial times 65 minus 15. I pressed the wrong button. Factorial. It's ginormous. It is 2.073. We'll stop there. No, we'll stop at 7. Times 10 to the 14th power. So on your calculator, the E is scientific notation. So if you were to write this number out, and I did on my notes, it's 207 trillion. We can leave it in scientific notation. 207 trillion. Now, all of these things, the use of factorials allowed us to do combinations, and combinations are going to allow us to do the binomial theorem. Now, what is the binomial theorem, you may ask? Binomial theorem is a shortcut for us to be able to expand binomials. Meaning, and don't write this down because I'm just showing you some things. If I had x plus 3 raised to the 5th power, that's the same thing as saying x plus 3 times x plus 3 times x plus 3 times x plus 3. One more time, times x plus 3. Now, I don't know about you, but I don't want to multiply that many times. That would be like 2 FOIL questions and then a trinomial times a trinomial and then yet another binomial. That's a lot of multiplying. Chances of you making a silly arithmetic mistake early and it messing up the whole problem, strongly high. So mathematicians have created this theorem that allows us to do a shortcut to expand equations like this, and it's called the binomial theorem. It looks mighty ugly until I explain to you what's happening in the binomial theorem. So let a and b be real numbers, so we're not using imaginary numbers. For any positive integer n, that's the power, we have the following expansion. A plus b to the n can be written as n choose 0 times a to the n b to the 0 plus n choose 1 a to the n minus 1 b to the 1. It's a lowercase a? Wait, where? There, yeah. Then we have n choose 2, a to the n minus 2, b to the 2. Do you kind of see the pattern here? The choose number is going from 0 and getting bigger every time. Well, that pattern is going to continue until I have n choose n, or I reach the same number. I would have a to the n minus n and b to the n power. Now again, that's a lot to write down, so we have simplified it into a summation notation, which I know I did not go over, but if you took pre-cal before, you've seen that summation symbol before. It's saying continually add, but every time you're going to take r starting at 0 and increase it by 1 until you reach n, and here's the pattern. But notice this pattern is exactly what I've done here. You have, and I'm going to put a little cloud around this because it's super important. Each time r gets bigger, but n stays the same. The a and the b stay the same, or the x and the number stay the same. Okay, so let's see this in practice, and I know your first practice problem is on the opposite side, but I will write down this on the next page so you can see it without flipping back. The way we're going to expand this binomial is using that binomial theorem, which was the summation from r equal to 0 to n choose r over a to the n minus r times b to the r. We're going to fill in what we have each time. I would use your small handwriting on this kind of problem. In part A, when we're expanding the binomial using the binomial theorem, for us, in our formula, a is going to be represented by x. B is going to be represented by 2, and n is going to be represented by 5. So here's where I got that from. The first part is A. The second part, whatever number's there, is B. Your n comes from the exponent and is used multiple places. The r starts at 0 and gets bigger every time until it matches n. It cannot be bigger than n. It just matches n. So if we were expanding this, here's what it looks like. We would say this expands to n choose 0, so 5 choose 0, times x to the 5 minus 0 and 2 to the 0. Plus, and now switch all of the r's by 1. This is 5 choose 1 times x to the 5 minus 1 times 2 to the 1. Get bigger. 5 choose 2, x to the 5 minus 2, 2 to the 2. I can't show everything at once because my handwriting would get too big. Then we have 5 choose 3, x to the 5 minus 3, 2 to the 3, plus 5 choose 4, x to the 5 minus 4, 2 to the 4. One more, which we might have to squeeze in there. 5 choose 5 times x to the 5 minus 5 times 2 to the 5. Woo-wee! All right, let me zoom out and let you copy. I don't even know if it's big enough for you to see. Once we have the binomial theorem written all the way out, we go in term by term and simplify. Meaning, we do 5 choose 0. Now, we just saw how to do this in our calculator. This would be 5 factorial over 0 factorial times 5 minus 0 factorial. 0 factorial is not 0, so it's okay to put that in the denominator. In your calculators right now, please do 5 choose 0. You had the formula on the front page if you need to flip it back. 5 choose 0. What'd you get when you put that in a calculator? Awesome, we got 1. Then we're going to have x to the 5 minus 0. What is 5 minus 0? Okay, yeah, 5. And then we have 2 to the 0. What's anything to the 0 power? 1. Okay, we've simplified the first term. We move to the second term. We do 5 choose 1. Again, that's a calculator question for us. 5 factorial over 1 factorial times 5 minus 1 factorial. So for 5 choose 1, we get 5. X to the 5 minus 1 is x to the 4th. 2 to the first power is 2. We keep going. 5 choose 2, we do the same thing in our calculator to do that combination. 5 choose 2 is going to give you 10. X to the 5 minus 2 is 3. 2 squared is 4. Five choose 3, again going back to that combination, also is 10. X to the 5 minus 3 is 2, and 2 cubed is 8. Five choose 4, if we do that in our calculator, gives you 5. X to the 5 minus 4 is x to the first power, and 2 to the fourth power is 16. Last but not least, 5 choose 5 returns 1. X to the 5 minus 5 is x to the 0. What's anything to the 0 power? 1. And then 2 to the 5th is 32. All that's left now at this point is to multiply all of the coefficients together to simplify it into what typically looks like a polynomial function. 1 times 1 is 1, so this is x to the 5th. 5 times 2 is 10, so this is 10x to the 4th. 10 times 4 is 40, so that's 40x cubed. 8 times 10 is 80, so that's 80x squared. 16 times 5 is also 80, so this becomes 80x. And then 1 times 32 is 32. So this whole polynomial here, this 5th degree polynomial, is what you get when you multiply out x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. We just didn't have to do that much distribution in FOIL. There's way less chance of error on arithmetic when you're using the binomial theorem instead of just straight up multiplying. It also takes less paper. Feels long, but it's actually a shortcut. Now I went kind of fast through that, so what are your questions? So if we look down at this next one, let's do how we started A, and let's identify A, B, and N. In this problem, what is going to be A? 3y. The whole first term becomes A in my pattern. What is B? 2. That's nice. Powers of 2 are nice. And what's N? 4. A smaller number. Hooray! So we actually are not going to have to expand as many times because it's only to the 4th power instead of to the 5th power. So if we follow the pattern that we have written at the top of the paper, I'm going to start the first one, and I'm going to let you finish writing the second, or all the rest of them, so you can see if you got it. This would be 4 choose 0, 3y, all raised to the 4 minus 0, times 2 raised to the 0. Now, I had to put that 3y in parentheses because if you didn't, it would look like you're only taking y to the 4 minus 0 power, but you're taking that entire term, 3y, to the 4 minus 0 power. Can you write the rest of the terms for me? Don't have to evaluate yet. I'll come with you for the evaluation, but just go ahead and see if we can write out the binomial theorem, all of the summing parts. Okay, how'd we do? Get it where you can see all of it. Are we all right? Okay, So now comes the part where we just simplify numbers. The choosing part, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, is the combination formula from the front of the page. So 4 choose 0 would be 4 factorial over 0 factorial times 4 minus 0 factorial. Bleep, bleep, blop. You would put that in a calculator. You would get 1. And then we have to take all of 3y to the 4 minus 0 power, where 4 minus 0 is 4. So we're taking both 3 to the 4th power and y to the 4th power. 3 to the 4th power is 81. And then you would have y to the 4th power. And then 2 to the 0, which is the last thing I'm multiplying in this term, 2 to the 0 is 1. Do we see how I did each of those pieces? Can you try to do the rest of them? Maybe. Love that. Okay, how'd we do on this one? On expanding. Ooh. Little different because we actually had to multiply the power or raise the number to the power that was attached to the variable. Makes it a little bit more complicated. But my last step is still the same. I'm still just going to multiply all the coefficients together, but this time not just the two numbers in parentheses, but also the coefficient of the variable immediately in front of it. So this first thing, 81 times 1 times 1 is 81y to the 4th power. 4 times 27 times 2 is 216, so 216y cubed. 6 times 9 times 4, also 216y squared. That's not like always going to happen where there's a double number. It just happened to be the examples I chose had those doubles numbers. 4 times 3 times 8 is 96y. And 1 times 16 is 16. So without having to double, triple, or quadruple distribute, we were able to multiply 3y plus 2 raised to the 4th power quickly. Questions, comments, concerns? When I do these kinds of problems on my own, I take my piece of paper and I turn it sideways so that I can write in one long stream without having to break it. So when you're working the problems on your homework, consider taking your piece of paper you're doing the problems on and turning it sideways so it's long instead of tall so that you can write more on each line. But of course, another type of question I could ask you here wouldn't be to expand the whole thing, because that takes forever. What if I was only interested in one particular term? Based on the expansion that we just did of a plus b to the n, we can find the r plus 1st term of the expansion by following this formula. We would do n times, choose r, a times n minus r, b to the r. So just one of those multiple things I'm adding together would help me figure out the particular term instead of the entire thing. But notice here, we're talking about the r plus 1 term, which means I'm not using the number that I care about. If I ask you for like the, let's say, the 7th term, we're not using 7 as r because 7 is r plus 1. So we actually have to take a number away from it to find the 7th term. What I mean by that is, if I ask you for the 7th term, that means that r is going to be equal to 6 because this formula helps me find the r plus 1 term. So 6 plus 1 is 7. That would be the 7th term. Okay, So if we were finding the seventh term of y plus 3 raised to the 8th power, because like, ew, we'd have to do 8 or 9 separate little things. That's a lot. We follow the formula where it says start with n, that's 8. We choose 6, which is the number we care about. 8 choose 6 times the first thing, y, to the 8 minus 6 times b, which in this case is 3, to the r, or to the 6. Notice I use 6 on all of these to find the 7th.
Can you explain how you got the 6 and the 7 again?
Yes, so the formula here is the r plus 1. So like technically what I did here, if r plus 1 is going to be the 7th term,
Okay.
what is r?
6.
6.
Oh,
Yeah.
okay.
So it's like 1 less than what you're looking for, if that makes sense.
It's always 1 less?
If it says the 7th term, r is 1 less than that.
Okay.
Okay, so here we go. We find 8 choose 6, which we would turn to our calculator for. 8 choose 6 would be 8 factorial over 6 factorial times 8 minus 6 factorial, bleep, bleep, blah. We've done a lot of those today, so we're going to fast forward. That's going to be 28. If you need help with that part, see me after, and we'll go over it again. Y to the 8 minus 6, that's y squared. And 3 to the 6th power, don't say 18, is 729. So again, to find that term, I just multiply the coefficients together. 28 times 729 is 20,412 y squared. So in the expansion of y plus 3 to the 8th, if I plucked out the 7th term, the 7th piece of the puzzle, that's what it would say. So again, I chose r based on it's the 1 less than the term you're looking for. But I could ask a different question. If I was asking you to find the coefficient of y to the 8th in the expansion of 2x plus 3 raised to the 10th, I didn't tell you what term it is, so we don't know what r should be. So we do a little bit of thinking. If you're raising something to the 10th power, that means the biggest exponent is going to be 10. That's the first term. Here's the second term. Here's the third term. Oop, what? Wrote what I said out loud instead of... What term is, x to the 8th or y to the 8th? Well, this is the first term, this is the second term, this is the third term. So we're looking for the third term. Again, the reason I figured this out is because the biggest power is going to be with n, and then they get smaller each time. So the 8th one is the third term. Now, if I'm looking for the third term, what does that mean r is going to be equal to? 2. Now I know what to plug into my formula. This would be 10 choose 2 times 2x to the 10 minus 2. Why'd I put that 2x in parentheses? Yeah, both of them are there in the first position, so I include both in that spot. Multiplied by 3 raised to the 2 power. Again, I'm going to fast forward through 10 choose 2, that combination. If you don't know where I'm getting these numbers from, see me afterwards. But 10 choose 2 is 45. We would have 2x raised to the 8th power. Well, 2 to the 8th power is 256 x squared. I mean, not x squared. I'm so sorry. That should be an 8. Okay. And then 3 to the 6th power. Nope, I'm looking at the wrong example. 3 squared is 9. We multiply all of those coefficients together. 45 times 256 times 9. We get 103,680 x to the 8th. Now notice if it says what is the term, this is the entire term. But this one specifically asks for the coefficient. So the coefficient is the 10,3680, the 103,680. So technically, this is what this question is asking for. Most of the questions I'm going to ask you is for the entire term. But if it happens to ask you for the coefficient, just type the number and not the variable in power.
So if it doesn't tell you to find wait.
Yeah, so because this question specifically said find the coefficient instead of find the term. This one up here says term. So we found the whole term. But if it says coefficient, we just want the number.
Did you get
The
the 2?
choose number?
Not the 2.
This one too?
And the R.
This one.
Yeah.
I got it. Okay, let me back up a second. If I know I'm doing to the 10th power, the biggest exponent is going to be 10. And then it gets smaller every time. So 10, 9, 8. I want to know the coefficient of y to the 8th. 8th is the 1, 2, 3 term in this series.
Okay.
So I say it's the third term, so subtract 1, r is 2.
Okay.
Yeah, good question.